So when I'm looking at this, I'm looking at that -1. That makes it go down 1. That's the last thing I'm going to do. This +2 inside here. What does that +2 do to my graph?
Left.
It moves it left.
I'm sorry. Can I go to the bathroom?
Yeah. What does that negative on the outside do?
That moves it down.
This one moves it down. What does that negative do?
Reflect.
It reflects it x-axis or y-axis? X-axis. So that's going to reflect across the x-axis. So I generally just put like x-axis.
Yeah.
All right, let's go ahead and move it left 2 first. So left 2 would look something like this.
That's not left.
Ooh.
Oh,
Oh, you got it. You got it. All right, let's actually go left 2 this time. All right, we'll go left 2, and then it says that we're going to reflect. So instead of being left 2, we are going to then go down. I'm going to do this kind of lightly so I can see my finished product. So that's my reflected is light green. Let's do our final answer in red. So that means I'm going to shift down 1. So that right there is my final answer. That is my negative x plus 2 squared minus 1. What's the domain of that function? I don't know. We have part of it. Infinity. Okay, what's the range? Yeah. What's the range, though?
Negative infinity, including -1.
Including -1. How would I write that on here, though?
Parentheses like a c, negative infinity, comma, -1, and then a backwards square-shaped c.
A square-shaped C? All right, so yeah, it goes negative infinity to -1. So that would be C. All right, when is it increasing? When is the graph increasing? Someone new. You got Emma. Safa? Negative infinity to -2. Do I put a parenthesis or a bracket on -2? Parenthesis. We always use parentheses on increasing, decreasing, and constant. When is it decreasing then? Same 3 people? Someone new? Yeah.
-2 to infinity.
It is -2 to infinity. Perfect. And the hardest one, when is it constant? No. Never. You're just waiting for that one? You're like, I could get the other ones wrong, but I'm pretty sure it's never. All right. That's it. That'd be a big problem on a test. Yeah, because it's got everything. It's got transformations, it's got range, it's got domain, it's got increasing, decreasing. I know. So you'd be crushing that test on Thursday.
like this Thursday?
Like this Thursday, but next Thursday. But it's like this Thursday, but it'd be next.
Like not yesterday.
It's similar, but different.
So we have this test and one more as the final?
Yeah.
Yo.
Okay. Let's go over homework questions real quick.
I never.
Yes.
On 25, on the answer sheet, it says that the square root of x plus 2 and like goes separate from the 2. And I put it all under the square root.
Let me look real quick. I was lost in the sauce for a second. All right, so we have the graph of, so you're saying you're putting everything under the square root?
Yeah, is that not correct?
That would not be correct because if it's underneath the square root, it'd be moving left 2. Because that means it's in the parent function. All right, let's go ahead and talk. So I think you're talking about, so if I would have y equals square root of x plus 2 versus y equals square root of x plus 2. See how this is, if this is under the square root, that would go left. So that actually goes left. If it's outside the square root, then it's going up. So anything inside the square root, inside where it's being squared. So x plus 2 squared versus x squared plus 2. Just be careful where it is. Inside, left or right. outside, up or down. Yeah. 33 says the graph of y equals absolute value of x is reflected in the x-axis. It's stretched by a factor of 3. Then it's translated 7 units to the right and 9 units upwards. So real quick, y equals, if I would go a times x minus, I guess, b plus c, that c term would make it go up, down. B would make it go left, right. A would be your scale factor. So if we look at that information, it says it's being stretched by a factor of 3, so that A becomes 3. It says that it is 7 units to the right. So to move right, it actually has to be a negative 7. And then it says it has to move upwards 9 units to be plus 9. But it does say the whole thing is reflected over your x-axis. So that means we're going to put the negative on the outside. If it says reflected over the y, I'd put the negative right in front of the x. But since it's across the x, we're going to put our negative out front. So those are things. I think that's probably the easiest way, because people mess these up on the test, is to just go write this out and just go, okay, A is my stretch, B is left or right, C is up or down, fill in those terms, and it makes it a little easier on yourself.
Yeah, my main question was like, so I had that, but I had like y equals parentheses -3 absolute value of x minus 7 and parentheses. Like, so why is it in the absolute value bracket?
Like this?
Yeah, but I had the absolute value just around the x.
Oh, just around the x.
Yeah, and then the parentheses around the x.
So you had y equals parenthesis,
Yeah,
-3,
yeah,
absolute value of x,
yeah. But then minus 7 and then parentheses
plus 9.
Yeah.
So I think that goes to the same thing that Jacob was asking about. See this square root? It really is your parenthesis.
Okay, so if there's like a different parentheses thing there,
Yeah.
just put it under there.
So you can kind of think of this absolute value bar as being the parentheses for that parent function.
Okay.
Okay? So when we have like x plus 2 squared, it'd be the same thing as x plus 2, all of it in this. So your parent function is whatever's between your absolute value bars. Your parent function here is everything that's underneath the square root. So anything outside the square root is up or down. Anything outside the absolute value bars is up and down. So if we look at yours, see how this -7 is outside the parenthesis bar?
Yeah.
So in fact, this would cause it to go up or down. And in fact, we'd have to just, this would go down 4, up 9, so it'd actually go up 2. Okay? So between the absolute value bars is inside of your function. Underneath your square root is inside your function. Emma?
Will we have to like reflect like a cube function?
Sure.
Does that just mean it goes like to like
Yeah. Just look what direction you're doing it in. So if I have a cube function, if I'm going across the y, I'd turn this way. If I was going across the x, it would just flip that way.
so it's just like zoop?
Yep, it just goes zoop.
Okay.
Yep. An easy way to go zoop across the x-axis is just change your y values from either negatives to positives or positives to negatives.
Alright.
All right, other questions on the homework? Okay, then we're just going to start off really quick with even and odd. There's usually a whole lesson on this. I condensed it to just 2 little quick problems because it's not the biggest thing in the world. Some people think it's the biggest thing. It really isn't. So we're going to really graze over this, and we'll talk about the more important part of this lesson after this. So it says a function is even. What makes a function even is if f of x equals f of negative x for all values of x. And what I mean by that is if I plug in 1 and I plug in -1, I get out the same answer. If I plug in 2 and -2, I get out the same answer. So my example is over here. It's a parabola. If I'd plug 1 in, my y value would be 2. If I'd plug a -1 in, my y value would also be 2. No matter whether I'm plugging a positive or a negative x value in, I will get the same y value out. The easy way to see if something is even is you're going to see if it's reflected across the y-axis. It is reflected across the y-axis. That will make it an even function. So if it's on the same thing on the right-hand side of your y-axis as the left-hand side, you then have an even function. That's why it says, in other words, there is symmetry about the y-axis. You can flip it and still see it. That is the long and short of even. Now we'll go to odd. Well, the difference between odd is a function is odd when you have a negative f of x that will equal an f of negative x for all values of x. All right, so if I plug in x, I get out a positive f of x. If I plug in negative x, for even, I get the same answer out. For odd, you get the same answer out except for its negative version. So let's say this is 2. It's not quite at 2, but let's say if I plug in 2, I get out 3. For it to be an odd function, if I plug in -2, I better get -3 out. So for even functions, you'll get the exact same thing out. For odd functions, you're going to get the negative version out. So once again, if I get 2, 3, if it's an odd function, I know I'm going to get out -2, -3 out. The negative version of it. This is called symmetry about the origin, where for even I can just flip it straight across and it will match up. What odd is you need to actually rotate it 180 degrees around here and it will match up then. That is symmetry about the origin. So that is our odd function. That is about all we're going to talk about for even and odd today. Today what we're going to really look at is using transformations to solve for particular problems. So we're going to talk about how can I graph it and then actually get this answer out. So we are going to graph absolute value x minus 2 minus 3, and we're going to figure out where that actually equals 0. So the first thing I'm going to do is I'm going to draw the parent function. Our parent function is absolute value of x. So I'll look something like that. So that is my parent function. That is absolute value of x. What does a -2 do? Nora?
Over to the right.
Moves it over to the right. 2. What does a -3 do? Mary? Moves it down 3. So what we're going to do to all of our points is we're going to move it right 2 and then down 3. So rather than being here, I'm going to go over 2, down 3. So our final graph, let's make that green. That sounds like fun. So over 2, down 3 is going to be right here. And I do the same thing for all of the points. So this point right here, over 2, down 3. Down 3 would be here. So we'd have that point. And we'd flip on the other side. If we did that for all our points, it would look something like this, like that, and that's enough. So that is, once again, over 2, down 3. That is our new graph. That is our absolute value of x minus 2 minus 3 equals 0. What this is actually asking me is this saying, what number can I input for x where I'll get an output of 0? Note our inputs are right here. Your outputs are your y values. So it's asking you what x value has an output of 0. And note, so if I plug in 2, I get out -2. If I plug in 1, I get out, I'm sorry, that would have been -3. If I plug in 1, I get out -2. If I plug a 0 in, I get out -1. If I plug a -1 in, I get 0 out. So if they're asking me for what x value do I plug in to get out 0, I'm going to circle the values that have a y value of 0. What will show up? Purple. So I'm talking about right here and right here. Because those points, this point right here is -1, 0. And this point right here is 5, 0. If I input -1, I get out 0. If I plug in 5, I get out 0. So when they say use transformations to solve this equation, our answers are x equals -1 and x equals 5. It has two solutions. If I plug either one of those into the equations, I should get out 0. And if you check it, well, if I plug -1 in here, I'll have -1 minus 2, which is -3. Absolute value of -3 is 3. 3 minus 3 is 0. If we try the same thing for 5, 5 minus 2 is 3. Absolute value of 3 is 3. 3 minus 3 is 0. These aren't hard to check your answers. All right, this one's slightly different. This one says graph this and tell me where your values, when your inputs would be greater than 0. So we already have this graph, so let's copy it down. We already have the graph. It starts at 2, -3, and just goes up like that. So let's just copy that same graph down because it's the same thing. So we have 2, -3, and it goes up, 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 up. So they're asking me, what inputs do I have where it'd be greater than 0? So once again, if we think about our input-output, if I input 1, I get out a -2. That is not bigger than 0. If I plug in a 0, I get out -1. That is not bigger than 0. If I plug in -1, that equals 0, but that is not bigger than 0. However, if I plug in -2, I get out 1. If I plug in -3, I get out 2. If I plug in -4, I get out a positive answer as well. So let's do this in red. This one is not included because it doesn't quite work. It equals 0. But all the ones in this direction do work. And we also have the same thing on this side, where everything except for the value that pops out 0 will work. So when I ask you to read a graph, and where is that bigger than 0, you're going to locate your y-axis being 0, and anything above it will be your solution. So in this case, our solution would be -∞ until we get to -1. And since there's no equal to sign, we're going to use a parenthesis, and we're going to union that with 5 to infinity. Once again, these aren't super hard to check. I would just pick a value from here. I'd pick a value from here, plug it in, and make sure it is bigger than 0. Once again, input, output. This is saying what inputs get an output greater than 0. Your graph are a bunch of series of input outputs. All right, this one says use transformations to graph and solve this equation. So we have x minus 1 squared. Well, x squared, let's do it pretty lightly. X squared would just be this graph. 2 goes to 4. -2 goes to 4. This is my parent function of x squared. If I was using pencil, I would do it very lightly so you don't mess yourself up later on. Just very light tick marks so you can see it. So that is my just normal x squared. Well, they don't want me to graph x squared. They want me to graph x minus 1. It is inside, so it's going to move left or right. And since it's negative, it's actually going to move right 1. In this case, I'd move everything over 1. If I was using pencils, I'd make sure it's thicker than my regular x squared so it shows up. This right here is my x minus 1 squared. Here's where it says it needs to be less than 4. When I input something, it needs to come out less than 4. So let's talk about the input outputs again. If I plug in -1, I get out 4. If I plug in -2, I get something much bigger than 4. If I plug in 0, I get out 1. If I plug in 1, I get out 0. 2 turns to 1. 3 goes to 4. 4 goes to bigger than 4. So if I'm looking for where is the output less than 4, what I'm really thinking about is that line there. That line is y equals 4. They're asking me, when are the outputs lower than that line? Well, that's going to be anywhere where a graph is below that line. So I'm shading in exactly where it's less than that line. I'm also going to note it's not an equal to sign, so I'd circle the ones that are exactly at 4. Those are not included, but those are kind of your start and end points. So now it's saying what inputs work for this circle. Remember, your inputs are your x values. Mary?
Okay, negative infinity, comma 4 parentheses, minimum 4, comma infinity.
I think you labeled the stuff that wouldn't work.
Oh, I thought you said.
I'm looking for the ones that are strictly less than 4. Safa?
Parentheses, -1, 2, 3, parentheses.
Yep. So this answer would be -1, 2, 3. Parentheses on both because there's no equal to sign. Because if I look at what I shaded in, we're going to use our x values because they say what inputs work. Inputs are your x values, so it'd go from -1 all the way to 3. So Mary, what you named is basically the stuff I didn't shade in. You're doing the opposite. You would have been, Mary, you would have been correct if I said when is it greater than 4. Because that would be -infinity to -1, and then 3 to infinity. You get the slight difference, right? But that is it. That is how you read graphs for solutions. They're asking what inputs give you those particular outputs. All right, any questions for me on that? All right, and the rest of the time is yours to work.